So week 10, today we'll be discussing engineering mathematics, previous year questions related to that, and the topic will be definite integral and linear differential equations. So I feel that this definite integral topic will come with practice only. So we'll discuss one concept that you can use, you can try to use in most of the definite integrals and as far as gate is concerned, and you can get away with the answers. So we'll look at that concept, and in linear differential equation we'll look at the uh, first order linear differential equation and then general nth order linear differential equation, one question each, and we'll try to um, see what are the different questions, possible questions that can be asked. Okay, let's start. So the first question, GATE 2011, question number 28. What is the value of the definite integral 0 to a? The limits are from 0 to a. The fraction is root under x divided by a bracket on root under x plus root under a minus x bracket off. So this is the expression, and we are asked what is the answer for the definite integral of this. So if you have actually ever tried to look at the definite integral in your class, in your gate preparation or something, you will have definitely come across this question, and this is also a previous year question uh, asked in gate, because this question relies on a very basic trick that is taught to us when we when we are being taught the definite integrals, how to play with the limits, how to modify the equation to make it simpler. So you can pause the video and you can try this thing. Okay, so now let me solve this equation. So let's say this integral is I. We have 0 to a root under x plus a minus x. Now, if you remember the property of definite integral, that is, if I is equal to integral a to b f of x dx, then it can also be written as a to b f of a plus b minus x dx, right? So we are going to use same property here. And a lot of the times this property also is written as 0 to a f of a minus x dx. So that's just b, or the lower limit being 0 in this case. So we are not going to add one more formula. We will just stick to the original formula, and we are going to look at this equation. So when I write again, this integral in other form using the limits, we get a minus x, because a plus 0 minus x, and we get a minus x plus a minus x dx. Upon simplification, we will see that it is root under a minus x, root under a minus x plus x. So this is I, and this is the I integral that we denoted the variable name. Both are same. So what we can do, we can add these two expressions and we can write 2I is equal to, again, 0 to a, and x plus a minus x, and we can write this as this. Now the denominator is same, we can add the numerators, and when we add it, we'll see that this becomes same as denominator. So this is 1. So we are basically integrating dx, right? So what will be the answer when we integrate any constant? Let's say constant k dx, it becomes kx, right? Since there is a limit some a to b, we will not be adding any constant because this is a definite integral. So this will be a to b. So in this case also we have a limit. So it will be x 0 to a, which will be nothing but a, and our I will be a by 2. So this is the answer we are getting, and that is also one of the options, that is B. Okay, so this definite integral used just the basic trick from the definite integral concepts, and we look at one more question based on definite integral when we after we look at another previous year question for GATE after we finish the quota. Okay, now let's look at our linear differential equation question. Okay, so this question is first order linear differential equation. This is related to that. Now, why we are saying first order and uh, you know 1 degree linear differential equation? So, if you know the linear differential equations are written in this form, the general linear differential equation. They are like dny by dxn plus kn dn minus ny dx n minus 1 and so on till we have k1y is equal to x, or we can even say f of x. So this is your linear differential equation, and when we say linear we have degree equal to 1 and none of the functions of y are multiplied with another function of y or x. So when we say degree equal to 1, we mean that the power of the differential. So this is not like there is a, oh sorry, we don't have a power here. We don't have like any k power or any 2 power. These are all just 1. And when we say order, that will be the highest derivative that we have given performed in this particular expression. So order here in this general is n. So that's why we call this a linear nth order differential equation. Now, when the n is 1 and nicely we are given these kind of questions, then how do you think we should get these y? How do you think we should solve this equation? I think it is a very famous approach. One of the approaches that that is not very easy to forget. What do you guys think? Is my writing this equation like this helping, helping to recall that expression? Can you guys able to recall this? So this is nothing but the integral factor approach that we use, where we have integral factor as an exponential of integral of this p and dx, right? So when we perform this integration, so I will again give one more question related to this just to solidify the concept. So we have this integral factor. First of all, we try to segregate, make the coefficient of the the dy by dx as 1. So what if anything is multiplied here, you just divide the whole expression, whole equation by that and shift it to the y and x, right? And then after you do that, you find the coefficient of y. That will, if that is a function of x or whatever, that is a constant or it is a function of x, you keep that in a term called p. And whatever is on the right hand side of the equation, you keep that in a function called q. Then the integral factor, that is if, is given as exponential to the power integration of p dx. So that will be in this case 1 by x dx. And what is the integration of 1 by x? It is nothing but ln x. And when you look at this expression, you should immediately understand that this is nothing but the inverse. Like ln is nothing but the inverse of exponential. So we are going to end up with only x, right? So integral factor in this case is x. And how do we write the solution for this equation? Okay, yeah. And how do we write the solution for this equation? We write the solution as y into integral factor is equal to integration of q into integral factor dx. And also you can write plus x plus c, the constant here, or you can write it after performing this integration. It doesn't matter. So now let's write the equation. So y into x is equal to x, that is q, into x, that is integral factor, and then dx plus c. So y into x square we have here, x square integration is nothing but x cube by 3 plus c. Now move this x from left hand side to right hand side. So we have, so this is our expression. And what we have been given? We have been given another condition, that is y equal to 1, and at x equal to 1 the value of y is 1. So when we substitute this here, what will be the value of y we'll be getting? We will have 1 is equal to 1 by 3 plus c by 1. So c is nothing but 1 minus 1 by 3, that is 2 by 3. Substituting this back into the equation, we get y equal to x square by 3 plus 2 by 3x. So let's see if we have this equation into the, yeah, so we have a slightly differently arranged option, but we have x square by 3 plus 2 by 3x. So that is what we have here. Okay, simple enough question. We will have a little bit harder variation of the same kind of question, in which I would like you guys to also solve with me. And whenever, if you will solve slowly step by step, and you can also, I'll ask you to unmute your mic and maybe try to say few things. How do we proceed? Something like that. Okay. Now this is another question. I want you guys to solve this question. I will tell you, you have to use the same concept. A B fx dx is equal to a b f a plus b minus x dx. You have to use the same concept as we have seen in the first question that we have dealt with today. So let's see. Okay, now I'll also solve. Let's solve this together slowly. So we have I is equal to. So if you have solved this, you can type the answer in the comment, or you can uh, unmute your mic and tell the answer also. So we have I is equal to 0 to 1 log of 1 by x minus 1 dx. Okay, let's simplify this, or let's multiply this x with 1 and take the LCM and perform this calculation. Let's write it in this format. When you write this in this format, or maybe even if you don't write in this format, I am writing it just so that when we perform this operation, the calculation becomes more apparent. So this is your I. Now let's perform this operation. So what will be 1 minus x? We have to replace our x with 1 minus x. So log of 1 minus 1 minus x, 1 minus x dx, right? So upon simplification, we have 1 minus 1 plus x upon 1 minus x dx. And what is that? Log of x by 1 minus x dx. So if you are familiar with your logarithms, then you will remember that log of a by b is equal to minus of log of b by a, right? I hope you all remember this. More generally, 1 by a is minus of log of a, and even more generally, log of a to the power n is equal to n log of a. Okay, we use this actually previous here, right? Okay. So when you use this concept here, you will see that this is nothing but I is nothing but equal to minus I. That means 2I is equal to 0. That means I is equal to 0. So this answer is can be asked in a numerical integral type question. I is equal to 0. The answer for this question is 0. Okay. So again, we use the same simple concept, as we used in question number 1, and we solve this question. Whenever you have a definite integral, try to remember the rules that are there, and we can solve. I also don't remember all the rules. Since I chose this question, I knew we had to use this. So the only way to get good with these things is just to solve more and more questions. Okay, now let's look at this question. So this is the question in which I think we should, solve this question together. So let's write this question here. Consider the differential equation, this t square minus 81 dy by dt plus 5t into y is equal to sine t, and also the condition is given to us that y1 is equal to 2 pi. There exists a unique solution for this differential equation when t belongs to the interval this or this. So they are saying basically that this differential equation will provide us a solution y is equal to f of x. That solution is going to be valid in which of the following ranges. So minus 2 to 2 is like on the line minus 2 to 2. Within this range, this solution is going to be valid. Minus 10 to 10, within this range, this solution is going to be valid. Okay, so something like this we have to find out. Okay, so let's write the equation that we have been given. T square minus 81 dy by dt is plus 5ty is equal to sine t. Now, as I said earlier, what is this? This is a first order linear differential equation, right? Same as the previous year gate question that we solved. So what should we do? We have to identify our P and our Q. And to do that, what we want to do? We want to make the coefficient of dy by dt as 1. So let's do that. And we have P and we have Q. So what do you guys think P will be and what do you guys think Q will be? Can anyone tell me? Okay, I think it is too simple. That's why you guys are not saying. So this is 5t was already there, and then we divided the expression by t square minus 80. And then Q is again Sine t was already there, and t square minus 81. So this is our p and this is our q. Now using this p value, we are going to identify our integral factor. That is nothing but exponential integral of p dx. So e 5t t square minus 81 dx. Now here is the good part. Here is another thing to learn if you are facing difficulty in integrating this. Whenever you have, let's say you want to perform an integral and you have some kind of function, uh, some expression like t to the power k plus x or something, b t power k x and plus a, and then you have something on the numerator, that is t k minus 1. You see, if we write it like this, it becomes more apparent, right? How we have to proceed with this integral. We just have to assume that b t power k plus a is equal to some value, or let's say u. Then what will happen is du will become b into k t power k minus 1. And we can easily, then dt. We can easily replace this term with this and some other constants, and it makes our life for integration much more easier. Okay, so that's what we are going to do here. We are going to assume that our t square minus 81 is nothing but u, and then the differentiation 2t dt is du, because 81 is constant, differentiation is 0. So t dt is equal to du by 2. So when you put that into this integration, you will see that we have exponential 5 du by 2 by u, or maybe we can take the 5 by 2 outside as they are constants, and we will end up with e power 5 by 2 integration du by u, which will give us e power 5 by 2 ln u. Now, what do we know from the logarithm? We know from the logarithm that k ln x is nothing but ln x power k. So we use this concept here, and this becomes e power ln u power 5 by 2. Okay. Now this is the expression, and again from the concept that ln and e, from the concept that ln and exponential are actually inverse functions, we know that this is going to be u power 5 by 2. Let's put in the value of u. So our integral factor is going to be t square minus 81 power 5 by 2. Okay, so pretty big, pretty complicated expression, but you will see that we don't even need to solve the whole expression or the whole equation to get to our answer that is asked in the gate question. Okay, so what do we need to do? Now we know our integral factor. What is remaining? Y into integral factor is equal to integral factor into q dx, and then plus c also we can write. So let's write that. T square minus 81 to the power 5 by 2 is equal to, what is our q? Q is sine t by t square minus 81. So let's write this, sine t square minus 81 dt. Okay, here I wrote dx by mistake, plus c. So upon simplification, we'll have t square minus 81 3 by 2 sine t dt plus c, and y is t square minus 81 pi by 2. So final expression that we are going to go for solving this whole question is this. Now look at this expression, and now I urge you guys to answer me that if this is this is an expression given to you, and I am going to ask you that at what point this function is not defined. At what point this function will be undefined. Let's say we don't need to perform this integration, because when we perform this integration, either we get some another function, or we get some constant value. So let me just write gx on the numerator for that, and then gx plus c divided by t square minus 81 pi by 2. Now I am asking you, at what point this function is not defined? Tell me, what do you think? T is equal to 9. Very good. Yeah, that's what I wanted to hear. So we have t square, when t square minus 81 becomes 0, when the denominator becomes 0, then at that case this function is going to be not defined. So when t is equal to 9 or t is equal to minus 9, this function is going to be undefined. That is clear? Okay, so now when that is the case, we have to see in our question that which of these ranges includes these one of these two or both of these points. So if the range given to us does not include minus 9 and 9, then in that range the solution to this differential equation will exist, and that is what is asked to us, that a unique solution to this differential equation t belongs to the interval which to which. So what do you think is going to be the answer? In which of these options we don't see the value minus 9 and 9 coming within the two ranges? Option A. Very good. Shalin has given the correct answer. That is, option A is correct, because minus 10 to 10 both are coming, minus 10 to 2 minus 9 is coming, and 0 to 10 9 is coming, and here neither minus 9 nor the 9 are coming. Okay, so that's how we solve this question. Okay, good. Okay, so that was the linear, or we can say first order linear differential equation. Now let's look at some general nth order linear differential equation that we already saw. That is dn plus kn dn minus 1 plus kn minus 1 dn minus 2 plus 1 y is equal to f of x. Do you remember this kind of expression? So this is the nth order again, because d we write it as d by dx, and k's are all constants, and this is not power, just denomination of the variable. So kn is nothing but one variable, and kn minus 1 is another variable, whereas this is power. On top of d, whenever I put the value, it is power, and here is nothing but d is equal to d power 0. So I should actually write more correctly k1 here, so into d power 0, that is 1. So this is the nth order linear differential equation. Now, we are not going to go in much detail here, but I am going to leave some material so that you can refer to it. But you should remember from our classes. Now, why I am not going into detail? Because I don't think in our civil engineering we need to go that far into detail. I looked at previous year questions and I didn't see many questions related to what I'm going to teach. So I have just taken one normal question which will make you aware that these are also the type of questions that are asked. Maybe not in civil engineering, but other branches. So what is this question? We want to find the expression for y. Okay. And how do we do that? So if you remember that first we go for complementary solution. And there is a particular solution. What is the complementary solution? Complementary solution is the expression for y that we get by solving this polynomial that we have in front of us. This polynomial equal to 0. Remember this by solving this polynomial. So whatever function for fx we get by solving this. Okay. And what is particular solution? Particular solution is something which we get by solving. Let me reduce the size. By solving this equal to x. And particular solution, the formula or whatever the function that we are going to write, that is going to depend on x. And for the complementary solution, the fx, let me see, I think we have visible. Okay, good. Okay, so luckily the internet connection has come to a reasonable degree so that it is visible. Okay. Okay, so what was I discussing? I was talking about this. Yeah. So the express you will get two expressions. Y equal to, let's say, f1x from your complementary solution, y equal to f2x from your particular solution, and the complete solution will be complementary plus particular. So y equal to f1x plus f2x is going to be your complete solution. Okay, so we'll see. So I couldn't find any question in the previous year that the bunch of questions that I looked at, that they have actually asked us to get the particular solution. Maybe there are questions, but when I looked at it, I couldn't find. So this is the question that I found, where in GATE they have asked us to solve this, nth order or second order linear differential equation, but they have given the x value, that is the fx on this side, as 0. So we'll look at this question, but I have given you some material which you can actually look at and see how we proceed when we don't have fx as 0. It is actually just a matter of memorizing these steps. So for complementary solution, it is a little bit easier to look at the the steps, these cases. Usually you will get only mostly at max you can get up to 4 cases. This fifth one is very rare. That is, this whole topic is rare, so this fifth is not even asked in the exams, but these four topics are very common. So let's see. We'll solve this, and while solving, we'll look at the case what we have. So here we have an expression given to us, d square by dt square this plus 2 dy by dt plus y is equal to 0. Now let's write it in form of d square plus 2d plus 1 into y is 0. Now to get the complementary solution, we solve the quadratic equation in d. This is the equation. So when you look at this expression, we can see it is d plus 1 whole square. Okay, so the root or the solution for this equation is d is equal to -1 and -1. So two solutions are there and they both are repeating, right? So how do we go about doing this? So that's why I told, to get the complementary solution, we have to look at the roots. What is the root for this polynomial and whether they are same or not, whether they are complex or not. So the formula for the fx is f1x is going to depend on that. So let's see, we have two real roots and they both are same. When we look at this, so what are the cases we have? All the roots are real and different, then we have a simple expression. So if m1, m2, m3, these are the roots actually. So if they are real and different, we have c1, that is the constant, c1 e to the power m1x. So these are all the roots and they have their different constants. When the two roots are same, let's say m1 and m2 is same, so here they have given m1 m1. In that case we have a different kind of expression, that is c1 plus c2x e power m1x or m2x, whatever the value you want to keep here, and then rest of the things are similar as we have seen above. And when the when three roots are same, then you have to go by this. In case of cubic, that can happen. In case of power 4, that can happen. So, and if they are complex, you get something in this format. And if they are complex and equal, then you get something in this format, in the last one. But that is like very, I don't even think that that type of question has ever even come. So we don't need to use our brain space to remember this. These are all, I think, sufficient enough. Okay. So our case was real and two are equal, and the value, that is m1 and m2, they both are same, let's say m1, and the value is -1. So what was the function? Y is equal to c1 plus c2x e power m1x. So c1 plus c2x e power -1 into x, so minus x. This is our function. Since we have the f of x here on the right hand side of the differential equation as 0, we don't need to worry about our particular integral. So particular integral we don't need to worry about. Let's just put it as 0 here. And this is the complete solution here itself, which is the complementary, I think complementary only, yeah, complementary solution. Is it complementary? I don't know. Yeah, complementary solution. Sometimes I get confused whether it is complementary or conventional solution. Okay, so this is complementary solution. Now let's find out the value of C1 and C2. Let's see. Yeah, we need to find out the value of C1 and C2. For that we are given y is equal to 0, no, y equal to 1 at x is equal to 0, and y dash is equal to 1 at x is equal to 0. So let's try to get that expression. Y dash will be, simply we are going to use here the multiplication rule for the differentiation. So first let's differentiate the exponential. So e power x differentiation is e power x, but then we have to differentiate the minus x here, so it will be -1, and plus the differentiation of the polynomial, it will be c2 and e power minus x. So y dash will be minus C1, and we have C plus C2 minus x C2 e power minus x. Yeah, and y we have simply we have already written. So let's use the first one, first boundary condition that is given to us. Y at x equal to 0 is 1. So 1 is equal to C1 plus C2 into 0 e power minus 0. 1 is equal to C1. We have the value of C1 with us. E power 0 is nothing but 1, and this goes to 0. Now let's use this C1 in this expression. So y dash is equal to minus 1 plus C2 1 minus x e power 1 minus x. And that also is 1 when we have x is equal to 0. So 1 is equal to minus 1 plus C2 1 minus 0 e power minus 0, that is 1. So we get C2 is equal to 1 plus 1, 2. So let's put in the values of C1 and C2. Finally, what we get? Y is equal to 1 plus 2x e power minus x. So that is the expression that we are getting, 1 plus 2x e power minus x. Oh, you see, that's a bad habit of mine to always write the independent variable as x. So instead of t, I wrote the expression as x. Nothing, no need to worry. We have the expression. Did you guys see till this point? Was the internet connection on till this point? Okay, okay, thank you. Okay. So we obtained this expression y equal to 1 plus 2x into e power minus x. So we just write it as 1 plus 2t e power minus t. So this is the expression, that is the second option is correct. You can either take that screenshot now itself. So yeah, let me just briefly, 1 minute. Let me just briefly show you. So these are all the functions, possible functions for your complementary function. You will not get anything outside this, and based on your x, as I was saying. So this there here in this particular book they have written is at capital X, but you can just put it as fx. So I'm going to do that. So this is nothing but fx. So based on what is the x looks like. So if x is in exponential, then you follow these steps. And when you have sinusoidal function, then you follow these steps. And when you have normal function, normal polynomial, then you follow these simples. This is the simplest, I think. And after that, this exponential, and after that we have the sinusoidal function. So I think you can look at this and look at some questions, some of the questions. I don't think previous year questions are there are a lot of questions, previous year questions related to this, but you can look at some, I think, ESE, engineering services examination questions. They have these type of questions in them. Yeah, so that's all for today's session. Thank you guys for joining. And yeah, now if you have any doubt, then I can try to solve them, and we can discuss about that. Otherwise, yeah, it is okay. Thank you.